Children, what is the difference between living and non-living things? Yes, the living organisms are capable of doing certain functions. How do they are capable to perform these functions? And what do they need to perform these functions? Yes, there are certain biochemical reactions which takes place inside the body are responsible to be alive. And to carry out these biochemical reactions, they need energy. How do they get this energy? In the previous chapter, you have learned that humans are heterotrophic in nature. That means they derive food from the other organisms. So, who are the producers of this food? Plants. Yes, plants use the simplest molecules called carbon dioxide and water, and in the presence of sunlight and chlorophyll they prepare the food, which is starch. Along with this, they also produce water and oxygen. This is what you have learned in the first chapter, known as photosynthesis. So, photosynthesis is considered as the basic life process because it produces two valuable substances. One is food, the other one is oxygen. The other living organisms depend on plants for the sake of this food and oxygen. So as soon as we take the food, do we get the energy? No. This food is broken down into simple molecules and they are transported to the cells. In the cells, the food combines with the oxygen, then the energy is released. That along with the energy, some amount of carbon dioxide and water are also liberated. So the process of oxidation, why it is oxidation? The addition of oxygen is nothing but oxidation. When the food in the cell combines with oxygen and releases energy, along with the energy, what else are produced? Carbon dioxide and water. Dear students, you have learned the carbon dioxide and water react with each other to form the food. And the same food oxidized in the presence of oxygen to release the same carbon dioxide and water and liberates the energy. So where do this energy is formed? In the food. In between the atoms of simple molecules of carbon, hydrogen and oxygen, which is called food. When this carbon, hydrogen and oxygen are separated in the form of carbon dioxide and water, all the energy which is stored in between these molecules in the form of bond energy is liberated. That means the purpose of intake of food will be served when it is oxidized in the cell and converted into energy. This process is called respiration. The respiration is nothing but the reverse process of photosynthesis. The definition of respiration is, it is an energy releasing process during which the simple molecules of carbohydrates, proteins or fats are oxidized to form carbon dioxide and water with the liberation of energy. And this process takes place inside the cells. So it is called cellular respiration. So let us know about respiration. People around 15th century knows very well on breathing, that means inhaling air and exhaling air can produce heat. That heat keeps them alive because they have compared their bodies with the dead bodies. In the dead bodies, they did not find that exchange of air and their temperatures are low. So, they use the term breathing in those days. In the similar conditions, the scientists and the medical practitioners, they have used a specific term called respiration, which is derived from the Latin word called respire. The meaning of respire is to breathe. The process of respiration takes place in the cells, but before going to that, let us know the historical facts which deals with this exchange of gases. Children, you have learned in the first chapter Joseph Priestley's experiment. He assumed that the air is not a single component or a simple component, which can be a mixture of two components. Through his bell jar experiments, he has proved that there are two components present in the air. One is responsible for the food preparation by the plants, and the other one is responsible for burning and breathing. Later on, his contemporary Antoine von Lavoisier, who conducted experiments to prove the components of air, and he studied the properties of various gases, especially carbon dioxide, oxygen, hydrogen present in the air. He conducted experiments. Antoine Lavoisier, in 1774, he conducted several experiments to show the relationship of oxygen and combustion. This is also considered as theory of combustion. First, he had taken one glass tub with 3/4 water. He noted the level of the water, in which he has taken a charcoal powder in a small floating dish, and he covered this with a bell jar. He lighted the charcoal powder and left it. The charcoal powder has given dense fumes. After some time, gradually these dense fumes have dissolved in the water, and the level of the water has gradually increased. And he also observed that the weight of after combustion of charcoal powder, the weight of the leftover soup has increased. Later on, he continued the same experiment with phosphorus. He burned the phosphorus in the same bell jar, and the white dense fumes which are produced have dissolved in the water, and there was also increasing level of the water. Let us come to this conclusion. The carbon, when it combines in the presence of air, it combines with some substance, some component of the air, which is also suitable for respiration, which he considered as respirable air, and it produces fixed air or chalky acid gas, which is nothing but carbon dioxide. This carbon dioxide dissolves in water and forming an acid, carbonic acid. When he tested this dense fumes which are produced by burning the charcoal powder, they could change the lime water into milk. And the carbonic acid, when tested with blue litmus, it has turned a red color, indicating it is an acid. Later on, when he tested the same activity with the help of phosphorus, when phosphorus burns in the air, it produces phosphorus pentoxide. The phosphorus pentoxide dissolves in water and produces phosphoric acid. So, concluding both the activities, he felt that there is a component present in the air which is responsible for burning. After the combustion of that substance in the air, it becomes its oxide, and when it gets dissolved in the water, it produces its respective acid. So the component present in air, he named it as oxygen. The meaning of oxy is acid. Gen means generated or producer. So he called that gas as acid producer because in both the instances, the gas which get dissolved in water and producing the respective acid. Later on, he repeated the same activity with a metal like mercury. And when the metal was burnt in the presence of air, which has taken long time, and finally he observed that the oxides of metal do not produce the same acidic in condition. And moreover, it is not showing the similar property of charcoal gas which is produced on burning, which could not change the lime water into liquid. So he repeated these activities with the help of breathing also. He arranged a mask to his person and he collected the vitiated air, means the exhaled air, and he blown into the lime water, which could convert the lime water into liquid. So by correlating the activity 1, the burning of charcoal, which has released the carbon dioxide and converted the lime water into milky, forming a chalky acid gas. The same way, during breathing also, the exhaled air contains the same component which could convert the lime water into liquid. So, the gas which is evolved after the respiration, after the breathing, is nothing but fixed air or chalky acid gas. So, the amount of chalky acid gas in vitiated air is more. And the component which is responsible for this conversion and respiration are both same, which he called as eminently respirable air, which is nothing but oxygen. So, by consolidating these two events, he came to conclusion that respiration and combustion are similar processes. In respiration, during the respiration in human body, there may be two processes are occurring. One, the normal air, the common air, after entering into the lungs is becoming vitiated air, means it is converting into the vitiated air, or otherwise, from the common air, the respirable air is absorbed by the blood and the vitiated air is added to the common air. But later on it is proved the second one is correct. That means the exchange of gases takes place in the lungs, the oxygen gets dissolved in the oxygen in the blood and carbon dioxide is added back to the common air. He also assumed that to convert the vitiated air back into common air, the same amount of respirable air which is added to the blood should be added back to the environment. Children, can you say which process will add back this respirable air back to the vitiated air? That is nothing but photosynthesis. Yes, during photosynthesis, the plants utilize the fixed air or chalky acid gas and they produce the respirable air which is added to the atmosphere. As long as the respiration and photosynthesis occurs at the same level, the gases oxygen and carbon dioxide will be maintained same. But unfortunately, due to the deforestation, we are cutting down the plants and we are increasing the amount of carbon dioxide in the atmosphere. The Lavoisier also assumed that the conversion of bright red color of blood in the body is only because of addition of the respirable air to the blood. His assumption was proven correct after 100 years of his inventions, and the hemoglobin was discovered, which is the oxygenated blood is produced only by the addition of oxygen to the hemoglobin. After Lavoisier, John Draper, he explained that All living organisms obtain three substances from the environment. One is the combustible substance, which is called food, and a gas and water. These three substances are required by all living organisms. And these three substances, they undergo chemical reaction inside the body and they produce the oxides of either carbon, phosphorus or sulfur. Along with some amount of water is also liberated. So with this, they were very close to the process of respiration. So now let us know about how does the mechanism of respiration takes place in the humans. Let us know about respiration. It seems to be like intake of air and giving out of air is called respiration. No. The actual definition of respiration is the process of oxidation. The process of oxidation of food into carbon dioxide and water to release energy is called respiration. So here two things you have to remember. One is oxidation process. It is an oxidation process. What is oxidation process? Addition of oxygen. So in the presence of oxygen is required and release of carbon dioxide and water with the liberation of energy. So now, what are the requirements of respiration? We need food and oxygen. Yes, we have learned how food is supplied to the cells in the first chapter. So after assimilation of food, absorption and assimilation of food in the intestines, the food is circulated to the cells. So now food is available in the cells. Now oxygen should be supplied to the cell. This oxygen from the atmosphere supplied to the cell involves several steps. So these steps are nothing but the events of respiration. There are 5 steps involved from the entry of air into the body till the supply of oxygen to the cells. There are 5 steps present. The 5 steps are like this. The first step involved in the respiration is breathing. Breathing is nothing but intake of air into the lungs and giving out the air from the lungs into the atmosphere. I am repeating once again. Breathing is the first step of respiration, during which the air passes into the respiratory organ and again it comes out into the atmosphere. It is followed by the second step. The second step of respiration is gaseous exchange between lungs and blood. The air which enters into the lungs, from the lungs, the oxygen enters into the blood and the carbon dioxide enters from the blood into the lungs. This will follow the second step of the respiration. The third step is transport of gases. Oxygen from the lungs, it is transported by the blood to the tissues. This forms the third step of the respiration. The fourth step is again gaseous exchange between blood and tissues. So now where is the oxygen? The oxygen is now in the third stage. It is being transported by the blood. So it carries it to the cells of the tissues. The oxygen enters the cells and carbon dioxide is exchanged to the blood. Oxygen passes into the cells and carbon dioxide diffuses back into the blood. This exchange of oxygen to the cells and exchange of carbon dioxide to the blood will form the fourth step of the respiration. Then the final step and the most important event of respiration, that is cellular respiration. This is the actual process of respiration. Means in the first 4 steps the oxygen is being supplied to the cells, but the oxidation of food takes place in the cells, which is called cellular respiration. That means the oxygen combines with the food and the food is burnt to liberate the carbon dioxide and water vapor along with energy. This is the final step of respiration, which is called cellular respiration, which occurs inside the cells. Let us consolidate. The first step of respiration is breathing. So, as you know, breathing involves inhalation and exhalation. So, during inhalation, we breathe in the air into the respiratory organs. The respiratory organs are like lungs. And during exhalation, the air with carbon dioxide expels out. So, the exhaled air contains more carbon dioxide than the inhaled air. So, to prove this, let us conduct one small activity. In the form of activity, let us learn. Take a sideband tube as shown in the picture. Take 2 test tubes. In one of the test tube, take water and the another test tube lime water. Take 2 cold rubber stoppers. Arrange the tubes in such a way, and now keep the outlet air in your mouth and inhale the air through your nose very deeply. So, as you inhale the air pressure in both the tubes are regulated. After inhalation, follow the exhalation. So, you blow the exhaled air through the outlet air into the both tubes. You do not find any change in the test tube A because the water does not change anyway. And when the air is blown in the test tube B, the lime water turns into milk. So, during inhalation, you did not observe any change in the lime water. But during the exhalation, you could see the change of lime water into milky white because the exhaled air consists of high amount of carbon dioxide. So, with this help of activity, we can prove that exhaled air consists of more carbon dioxide when compared to the inhaled air. So, how do this carbon dioxide is added to the exhaled air? To know about this, we should know about the respiratory system. So, the air passes through the various parts of the respiratory system. It reaches the respiratory organ where this exchange of carbon dioxide and oxygen takes place, and the exhaled air consists of good amount of carbon dioxide.